by joining the midpoints of the histogram, you may get different types of shapes. You may get the first one, uniform. You are having all the frequencies, you are getting more or less same. If you are getting this type of outcome, you may say that your data set is following a uniform distribution. You may get a distribution where you are having longer tails to the right side. For example, in the Poisson distribution, exponential distribution, geometric distribution, all these distributions are having longer right tail compared to left one. So positively skewed curve you may get. You may get a curve where you are having same distance, you are having the same tails, same length tail, Gaussian or normal distribution, which we are often using it. So if your data sample which you are doing is following Gaussian distribution, then you may use parametric tests. There is a different approach. If it is following normal distribution, we are having a different approach for analysis. If your data set is not following the normal distribution, we are having a different approach for the analysis. Okay. Now, whenever we are looking at the distribution pattern of the data set, there are two important things which we should look. One is your skewness of your data set, and the second one is your kurtosis. Okay. What is this skewness? Skewness is a measure of degree of symmetry, asymmetry of a distribution. Okay. Generally, if your data set is symmetrical, as we are having in normal distribution, if you cut the normal distribution from the middle, both the halves are identical. Okay. You are observing yourself in a mirror. You are getting a symmetrical image. So if the data set is such that, then it is giving you an indication that it is following normal distribution. Any half you study, you will get the idea about the other half. But many times what happened, you might be getting a data set as we have seen in your exponential distribution, Poisson distribution, chi-square distribution, they are all positively skewed one. Okay. So if we are having a positively skewed distribution, the maximum point, highest point, frequency, more frequency means it is a mode. We are having mode, then median, then mean one value. If you are having left skewed, negatively skewed, then we would be getting a different types of inference. Okay. So whenever you see a graphical presentation or distribution of data set, look at the symmetry, what type of symmetry you are getting. Second important thing in your distribution which you should look at the kurtosis. So kurtosis is a measure of whether the data are heavy-tailed or light-tailed. What we mean by heavy-tailed, if you look at this middle one, heavy-tailed, we are having lot of data at the corners here. Only small amount of data is at the center, but major data is towards the extreme values. Okay. Ideally, what should happen? We feel that it should have a normal distribution. Major amount of data we should get here. Only less amount of data we should get at here. So if you are having a heavy tail distribution, that means here you are having extreme values. Data are not centered towards the central value. यहाँ पे value observation बहुत कम है, यहाँ पे observation ज़्यादा है. Light tail यहाँ पे observation बिल्कुल ही कम है, यहाँ पे बिल्कुल ही कम है. लेकिन ओवरऑल डिस्पर्शन कैसा है? बहुत ज़्यादा है. इसमें भी डिस्पर्शन बहुत ज़्यादा है, इसमें डिस्पर्शन तो कम है, लेकिन क्या है? सेंटरिंग सेंटर पे नहीं हो रही है. Here we are having more or less as we are at the center, as we move far from the center, the dispersion is increasing. Okay. So ideally, the most easy to study the distribution is your normal distribution, and it is very popular also because lot of biological variables are there which are following normal distribution. Okay. So I hope the concept of distribution is little bit clear to everyone. Anyone is having any query for the distribution? Anything? Yes. Please give.
Heavy tail and light tail.
Heavy tail means that you are having.
What is meaning of?
मीनिंग इसका ये है कि जो आपका सेंटर पे क्या आपका एवरेज वैल्यू होता है, तो आपके डेटा सेट में एवरेज से डिविएटेड वैल्यूज ज़्यादा हैं, यहाँ एक्सट्रीम में ज़्यादा है, यहाँ पे ज़्यादा है. सेंट्रल के पास में वैल्यूज कम हैं। जैसे हम बोले कि एवरेज क्या होता है, एवरेज मीन्स औसत, है ना। सो वी बिलीव दैट इफ आई से द एवरेज हाइट ऑफ दिस योर बैच इज दिस मच, सो आइडली आई फील दैट कि मोर और लेस ज़्यादातर लोगों का हाइट इतना ही होगा, ठीक है। लेकिन अगर ये हैवी टेल्ड होगा तो क्या हो जाएगा कि बाकी लोगों का वेट उस एवरेज वाले वेट से मैच नहीं करेगा, डेविएटेड होगा बहुत ज़्यादा आपके डेटा सेट में। दैट मीन्स योर डेटा सेट इज हैविंग एक्सट्रीम वैल्यूज, okay, because of which we are not getting lot of values close to the central. It is not following the ideal normal distribution. Okay, anything else? Heavy tailed, देखिए it is all when once you are making a histogram, by joining the midpoints of a histogram we can get these types of shapes. Okay, so if you are getting this type of shape, what is happening, this is the central value and with respect to the central value we are getting all these values. तो यहाँ पे ज़्यादा वैल्यूज है ना सेंटर पे, डिस्ट्रीब्यूशन सेंटर पे ज़्यादा है, वी आर हैविंग मोर वैल्यूज हियर, बट हियर यू कैन सी दैट वेरी स्मॉल डिस्ट्रीब्यूशन इज देयर, सिर्फ इतना ही डिस्ट्रीब्यूशन है। और यहाँ पे कॉर्नर में अगर हम देखें, यहाँ से अगर हम कट करते हैं तो यहाँ पे ज़्यादा है, राइट और लेफ्ट में ज़्यादा है, सेंटर पे कम है, ठीक है। तो जैसे हम बोलते हैं मेजर्स ऑफ सेंट्रल टेंडेंसी, ठीक है, तो यहाँ पे जो मेजर्स ऑफ सेंट्रल टेंडेंसी है जिसको हम मीन मीडियन मोड आप लोग बोलते हैं, तो हियर द मीन मीडियन मोड माइट नॉट बी द गुड रिप्रेजेंटेशन ऑफ द डेटा। व्हाई? बिकॉज डेटा इज स्कैटर्ड, ओके, एंड इन नॉर्मल डिस्ट्रीब्यूशन योर measures of central tendency is giving you the good representation of the data because major points variables are close to this central values, ठीक है। तो अगर एवरेज ऐसा है जो कि पूरे क्लास के बारे में बता रहा है, then you all are okay with that thing, but एवरेज कोई ऐसा है जो कि आपको रिप्रेजेंट नहीं कर रहा है, तो you will not accept that thing ना, कि no, he is not going with our characteristics, okay। कॉन्सेप्ट ऑफ डिस्पर्शन, ये थोड़ा चला गया, ब्लैक हो गया है, ओके। तो जो हम, यस यस प्लीज प्लीज,
maybe not exactly in this level, but when we are checking for like normality of data, normality of data when we are checking for, and before going for parametric test, non-parametric test, so ideally then we should check for both skewness and kurtosis.
Yes, yes.
Commonly what we do is we check only for skewness and both, right?
No, generally, sir, we generally, if you have seen that we are performing a testing of hypothesis. 𝐕𝐢𝐬𝐢 test is there, lot of more tests are there. All these tests are taking consideration of skewness as well as kurtosis also.
So they take care of both.
Ideally, we can independently also we can check the skewness and kurtosis, but when we are performing the normality testing of hypothesis, that test is taking care of skewness as well as kurtosis also. Okay, so the measures of central tendencies, as I have told, is that amount in which we are interested. So measures of central tendencies can be mean, median or mode, okay. I am not going into that thing, okay, but I am giving you a small example. Suppose after a critical surgery, okay, the years of survivals are given to you. The first patient is there who survived for 5 years, okay. Second patient is there who survived for 4 years. You can write down the data and you can find the average survival. It will take, or you can use your smartphone. First patient survived for 5 years. Second patient survived for 4 years. Third patient survived for 6 years. Fourth patient again survived for 5 years. And the last patient is surviving, say, 25 years. What is the average survival we are getting? 9. Okay, so we are having the data set. You told your unit head that key after the surgery we are getting 9 years of survival. He said that I have not seen this in my life. Show me your data set. Okay, you have gone on with the first patient. It is 5 years. See, he says it is not 9. The second one, it is 4 years. Again, it is not 9. The third one, it is 6 years. Again, it is not 9. Then the fifth one, it is 5. Last one, it is 25. and he make an inference that you are telling lie. Is the specialist wrong in his inference? वो गलत, उनका इन्फ्रेंस गलत है, उन्होंने कहा आपने मुझे गलत इन्फॉर्मेशन दिया है. Is it he wrong in his statement? मैंने तो आपसे पूछा आप एवरेज बताइए, आपने एवरेज बता दिया कि 9 साल है. So median and mode are no offense to the people at the east, but it's like that कि you people, we generally do not consider them as equivalent to arithmetic mean. Okay, so we generally, if someone asks that what is the average, we add all the things and we divide by the number of observations. Okay, ideally it should not be done. Whenever data comes to you, look at the dispersion overall. What is the picture of the data set? If your data set is having very extreme values, then go with a different measures. If your data set is having right skewed or left skewed, go with the median. If your data set is such that which is having most occurring values, okay, frequent occurring values, ECG findings you are having, go with the mode one. Okay, so look at the data, what is the nature of the data, then decide what central tendency we have to use. Okay, okay. Once we get the central tendency doesn't tell us the complete picture. We need to know what is the deviation from the central tendencies, how much other values are deviating from your data set. Okay, if you said that the average of a student which we have who have scored is say 80%. Okay, so the next question the people may ask is that on an average tell us the range, in what range the students are getting marks in your school. So the majority of students are having a range of say 70 to 90. Then you make an inference कि अच्छा ये तो बहुत 70 to 90 narrower है. कोई बोलता है कि ना we are getting from 45 to 95. That means that कि overall we are having a lot of dispersion. We cannot make inference precisely. So basically we are having 4 important measures to measure the dispersion in our data set. First, as I said, range. So range is just telling you the 2 values, the highest value and the lowest value. It is the most unscientific method to represent the dispersion. It is just telling you what is the overall dispersion. So if in your data set you are having 2 extreme values, you will be getting a range which may not represent the ideal situation. Okay, because it depends on 2 values, and if that 2 values are not the representative of your data, you will not get the exact dispersion. Second one, which we ideally generally use, is your standard deviation. Okay, we will come on this thing. This one we am coming, standard deviation. Okay. Suppose if you make a histogram, and by joining the midpoints of a histogram, you are getting this bell-shaped curve. So standard deviation will be telling you that on an average how much the values are dispersed from this central value, this mid value where we are having the 80. Okay, so if the values are very close to this mid value, central value, we would be saying that you are having the least dispersion. So dispersion, we have not written the formula. Okay, so the deviation कैसे पता चलेगा? Central value minus the observed value. Average, जो हमारा average value होगा, ये जो average value है, suppose average we have got 80, the first value which I am getting is say 50. So it might be lying here somewhere. So how much is the deviation? Xi minus x bar, 50 minus 80, 30-point deviation. Similarly, for the second one, we would be having some other deviation. So xi minus x bar will be having in the numerator. Standard deviation का जो formula है वो यही है, summation xi minus x bar the whole deviation. तो पहली वैल्यू का कितना deviation हुआ, दूसरी का कितना deviation हुआ, divided by number of observation. तो total deviation divided by number of observation, it's nothing but it's average. Average में जैसे हम लोग करते थे, सारे deviations को जोड़ दिया, divide कर दिया by number of observation. So standard deviation formula generally we have xi minus x bar the whole square divided by en. Okay, हम whole square क्यों कर रहे हैं, deviation को square क्यों कर दे रहे हैं? deviation. Very good, very right. Okay, so since we are having equal deviation, if you are not squaring them, it will cancel out each other. So to overcome from the sign, we are squaring them, and to overcome from the square, we are taking a under root. So that is the formula for standard deviation. Okay. Sorry. Sorry. एक सेकंड. हाँ, yes please. हाँ, तो उसका मीन हमको क्या मिला? 9 मिला था ना मैम. तो 9 मिला था इस डेटा सेट में. वी आर हैविंग एक्सट्रीम वैल्यू 25. So if your data set is having extreme values, then we should go with median. We should not go with the mean when calculating the average. Okay. So in your data set, if you are having extreme values, go for a median. If you are in data set, you are having most occurring, frequent occurring values, go with mode. Okay. I am not writing the formulas because you would be using software to calculate it. Okay. The standard deviation is clear to everyone. Okay. Now coming on the last one, that is coefficient of variation. Coefficient of variation, in short we call it as CV. Okay. Suppose the standard deviation, you are given two variables, say body mass index, and you are having another variable, say bone density. Okay. Both are measured and both values are given to you. Say bone density is having a lower value of standard deviation compared to your BMI. Will it be an indication that here the data is more closer to the central value compared to the first one? Can you compare these two deviations? We cannot compare these two deviations because they both are measured on different units. Okay. So we cannot compare apple with oranges because they both are measured on two different units. But suppose somehow we want to have a comparison of this statistics. Okay. Then what we use coefficient of variation. We wanted to know which data is more reliable, whether it is a bone density data which is more reliable or whether it is the BMI data which is more reliable. Then we will be using coefficient of variation. So we will be calculating coefficient of variation for the first data, and we will be calculating the coefficient of variation for the second data. Wherever we would be getting a lower variation, it means that that sample is more reliable compared to the other one. The formula for calculating coefficient of variation is standard deviation divided by mean into 100. Okay. So we would be calculating the variation of first data with respect to its mean. Okay. So coefficient of variation for the first data, we will be calculating SD, standard deviation for first data divided by mean into 100. Similarly, for BMI, standard deviation of BMI divided by the mean BMI. And wherever we would be getting a lower BMI, it will be an indication that your data set is more reliable compared to the other one. Coefficient of variation, is it clear? Okay. Interquartile range is nothing but it is used in a box whisker plot. Yes.
Coefficient of variation, we are dividing the mean, so it can be used only for the normal distribution data.
Yes, generally coefficient of variation formula, generally we have mean divided by standard deviation into 100. But if your data set is a very heterogeneous one, where the mean is not a reliable one, in that case it is not sensible to calculate coefficient of variation. Okay, whenever your data set is such that it is very extreme, then in that case whatever the measures which are based on mean should be avoided. In that case, go with the median. In that case, what we can use? We can use the interquartile range, IQR. Okay, so IQR is nothing but it is the interquartile range where it is based on three deviations. First one is your median, second one is your first quartile, then we are having the third quartile. So based on the percentile distribution, we are making a box whisker plot. And then we are comparing. If your data set is extreme, we would be making a box whisker plot. How to make a box whisker plot? In the hands-on training, you will get to know कि box whisker plot कैसे बना रहे हैं, ठीक है? But the motto for the box whisker plot is to get an idea whether your data set is homogeneous or in your data set there are extreme outliers or what? Yes, please.
IQR, where would we prefer to use it?
IQR generally we prefer when in our data set if we are having outliers. Okay, generally when before doing any analysis, it's a first step to have a scatter plot, to have a IQR, so that it will give you an idea ki in your data set how much is the dispersion. Suppose you have seen your data, okay, before going for further analysis, calculate its mean, median, mode, look at the skewness value equal to 0, that means symmetrical it is. Kurtosis value equal to 3 if you are getting, it is an indication it is following normal distribution. Okay, but if you are getting all these skewness value, you are getting positive or in negative direction. Kurtosis value you are getting higher than 3 or considerably lower than 3. It is giving you an indication that your data set might be heterogeneous in nature. In that case, go for a scatter plot, then make a box whisker plot. In that case, you would be getting an idea ki how much heterogeneity you are having in your data set. Okay. Now, standard deviation, can anyone, we have covered standard deviation. Can anyone just tell me in one line what does the standard deviation? From a layman perspective, if I say what is the standard deviation?
The average of dispersion of each variable from the each data from the mean.
Average of?
The variation of each data from the mean.
Yes, yes. Okay, so standard deviation is telling you how much each and every value is deviating from the central value on an average. Okay, on an average, this much will be the deviation. So on an average, if your deviation is very large, it means that your data set may not be reliable. But on an average, if you are having a lower value of deviation, it is giving you an indication that more values are close to the central value. So whatever average you are suggesting may be the representative of the population. If you are having a deviation very large, your average may not be the representative of the population. Okay. Now, there is another very important term which we call is standard error. So if you are getting a higher standard deviation, that means your central value, average, is not a reliable one. है ना? What does standard error tells? Standard error indicates how different the population mean is likely to be from sample mean. ठीक है? Standard error, उसको standard deviation बोल रहे हैं, इसको error बोल रहे हैं. Deviation और error में deviation ज़्यादा वो लग रहा है, खतरनाक लग रहा है सुनने में, या error जैसा लग रहा है कि ये ज़्यादा केयर करना चाहिए? Error. Okay. Error क्या बोल रहा है? Error बोल रहा है the standard error indicate how different the population mean is likely to be from sample mean. If we are interested in mean, say, ठीक है, if we are interested, say we are having, say in the population the diastolic blood pressure is say 80, and you have chosen a sample, from that sample you got 82. So how much deviation you are getting? 2 point. Sample mean का population mean से जो deviation है वो क्या कहलाता है? वो कहलाता है standard error. तो standard error is what? Standard error is deviation of sample mean from population mean. If you are interested in mean, तो in general अगर हम बोलें तो standard error is what? It is the deviation of sample characteristics from population characteristics. ठीक है, तो अगर आपका aim है about the prevalence, तो you can have standard error for prevalence, you can have standard error for incidence, you can have standard error for correlation. Population में correlation कितना है? आपको मिला population में correlation है 60%, आपको मिला 50%, तो that means the error which you are getting is 10%. बहुत ज़्यादा error मिल जाएगा तो क्या होगा? Representative नहीं होगा. Very right. तो representative नहीं होगा इसका मतलब you cannot generalize your finding. If it is not representative, you cannot generalize your finding. But in your data set, suppose you got slightly high standard deviation, but you are getting a lower value of standard error. It means that कि आपके sample में जो variation तो ज़्यादा है, लेकिन स्टैंडर्ड एरर कम आ रहा है, तो इसका मतलब कि आपका जो सैंपल है वो पॉपुलेशन को रिप्रेजेंट कर रहा है, आपकी सैम्पलिंग में कहीं गड़बड़ी है तो उसको थोड़ा सही कर लेंगे तो आपको गुड मिल जाएगा, ठीक है। तो स्टैंडर्ड एरर इज डायरेक्टली प्रोपोर्शन टू स्टैंडर्ड डेविएशन एंड इज इनवर्सली प्रोपोर्शन टू योर सैंपल साइज n, ठीक है। तो स्टैंडर्ड एरर is used for mean, standard error can be used for any characteristics in which you are interested. तो population का characteristics जिसमें हमारा इंटरेस्ट होता है उनको हम स्टैटिस्टिकल टर्म में कहते हैं पैरामीटर, एंड सैंपल की कैरेक्टरिस्टिक्स जिसको पढ़ के हम उसके बारे में फाइंड आउट करना चाह रहे हैं उसको हम बोलते हैं स्टैटिस्टिक्स, ठीक है। तो सैंपल कैरेक्टरिस्टिक्स इज कॉल्ड स्टैटिस्टिक्स एंड पॉपुलेशन कैरेक्टरिस्टिक्स इज कॉल्ड पैरामीटर, ठीक है। तो स्टैंडर्ड एरर इज गिविंग यू आइडिया हाउ क्लोज योर स्टैटिस्टिक्स इज विद रिस्पेक्ट टू द पॉपुलेशन पैरामीटर। तो अगर स्टैंडर्ड एरर बहुत कम मिल रहा है इसका मतलब आपका जो सैंपल है, वट एवर द सैंपल यू आर गेटिंग इज अ गुड रिप्रेजेंटेटिव ऑफ द पॉपुलेशन, ओके। दैट्स वाई योर मेंटर्स माइट बी टेलिंग यू दैट इंक्रीज द सैंपल साइज, ज़्यादा सैंपल कवर करिए, ठीक है। तो n से इनवर्सली प्रोपोर्शन, जैसे वो बढ़ेगा वैसे ही ये कम होगा, okay. So I hope the concept of standard error is clear to everyone, okay. Anyone is having any doubt with the standard error? Okay. Now coming on confidence interval, okay. Very minimum formula I have tried to put, okay. Confidence interval जैसे बोल रहा है, interval का मतलब कि there might be some lower limit, some higher limit, है ना। कॉन्फिडेंस इंटरवल क्या बोलता है? When you make an estimate in statistics, there is always uncertainty around that estimate because the number is based on the sample, ठीक है। You are making inference about the population. We all are interested in the population ना। आप जो whenever you are doing a study, any type of study design, whether RCT or whatever you are doing, whatever the inference from your sample you would be getting, you would be commenting that in a population this is happening. You would try to generalize your finding, okay. So whenever you are doing a sampling, there will be some amount of error, okay. So we want to reduce that error, or rather than we want that our estimate, we want to put more emphasis on our estimate, how to make it little bit more reliable, okay. So we try to this using confidence interval. Suppose if the quantity of interest is mean, then a confidence interval is the mean of your estimate plus minus the variation in that estimate. जैसे हमने बोला आपको standard error बता रहा है, what बता रहा है? It is telling you that how much variation in the population you are having with the population characteristics, ठीक है। What is the difference between your sample characteristics and population characteristics, ठीक है। So confidence interval, how you are calculating? You are having your estimate. You are interested in the mean. You have calculated the mean x bar. Then what you are doing? You are calculating the range. प्लस माइनस, यहाँ पे प्लस माइनस करके हमने स्टैंडर्ड एरर लगा दिया। इसका मतलब लोअर लिमिट इतना हो सकता है, हायर लिमिट इतना हो सकता है। दैट मीन्स यू आर गिविंग अ इंटरवल, है ना। इफ यू से दैट द फॉर अ पेशेंट, if you are saying him that the disease duration is 6 days, okay, is it more precise? Or if you say that the disease duration can be of say 4 days to 8 days, okay, obvious the actual values may lie in the interval, may not lie on the point, okay. So whenever we are in nowadays we are having more emphasis on the confidence interval rather than on the p values, okay. P value is a single value, okay, but confidence interval is giving you a possible range of values where your sample values can lie, okay. So confidence interval we are calculating with the point estimate plus minus standard error. वहाँ मैंने स्टार लगाया है स्टैंडर्ड एरर के पास में, ओके। स्टार लगाया है, जनरली वहाँ पे क्या है, डिस्ट्रीब्यूशन का वैल्यू होता है। स्टार इसलिए लगाया है, दैट इज नथिंग बट दैट इज योर कॉन्फिडेंस लेवल, हाउ मच कॉन्फिडेंस यू वांट, ओके। यू वांट 95% कॉन्फिडेंस, you would be having some values for that thing. In normal distribution we have a value of 1.96, ठीक है। If you want 90% confidence, ठीक है, that means in an experiment 90% times you expect that you would be getting these values, 10% there would be variation. So narrower the confidence interval, more precise your estimate will be. Okay. So if here we have written a general formula for mean, if you are interested in the proportion, what will happen? You will be having the point estimate for proportion plus minus standard error for proportion. You want to have the idea about the correlation. You will be having the point estimate of correlation plus minus standard error for the correlation. You want to have the estimate for regression, point estimate for regression plus minus standard error in the regression you are getting, like that. Okay. Now, this is the general formula for the mean. Point estimate plus minus, this is the confidence level value which I have put the star into standard error. Okay. So for mean we are having this formula SD by root over n. For proportion we are having a different formula for standard error. For correlation and all we would be getting a different formula. But in general it is inversely proportion to n and somewhat directly proportion to the standard deviation. Okay. So in general we are getting this type of this formula for mean, and you are having this 94% chance your population mean will fall within this limit. Okay. Suppose this is a little higher one, testing of hypothesis will be done, but I am just giving you a small idea. Suppose you are getting from this mean, you are getting a value 4.27, and someone asks that whether a mean of 4.27 and a mean of 5 is statistically different or not. And for this mean you have got this interval. This interval says that its values can be 2.92 to this range 5.62. That means your 5 is lying in this interval only. This interval will have that value 5. That means it is not statistically different from mean. You are having your null value within this interval range. So by just looking at the confidence interval, you can directly tell that no need to go for a testing of hypothesis. Your point estimate is having that value. So there is no need to do a testing of hypothesis. Okay. So it is more informative compared to your p-value. Okay. So I hope confidence interval is clear to everyone. Okay. Now the last one we are having sampling. Okay. A sample is some part of the larger body specially selected to represent the whole, that is a representative of the population. Okay. So often people quote that what is sample and what is population. If someone says the population, someone says that population is a very big body. Okay. But it is not like that, it is a very big body, because population generally means a group or an individual on which you want to generalize your finding. Okay, that group individual can be of length 100, can be of length of number can be of 10,000 or something different, anything. But population is a bigger body on which you want to generalize your finding based on the sample. Okay, the aim of the sample is to be representative of the population from where it was drawn. Okay, so if you want to study the attribute of a medical student, and instead of choosing a sample from IMS in BHE, if we are doing this study, instead of choosing the sample from IMS, we have chosen a sample from say a student from fine arts. Okay, the attribute sample is not the representative of the population. Whatever inference we will be getting will not be the representative. Okay. So sampling is a method with the help of which you are choosing your units, study units. So ideally what we are doing, what you want to talk about is the population. In the population, average weight at birth is say 2.5 kg. But you cannot cover the entire population. So what you are doing? You are choosing a small sample from this population. How you are choosing it? That is a sampling technique. And you are making inference from the population. So 2.5 kg is there, but you are actually getting 3. You are making an inference that in the population, the normal weight at birth is 3 kg we are getting. So generally the sampling process can be of two types. One is probability sampling and the second one is non-probability sampling. Probability sampling, that means if the units which you are choosing are having certain probabilities and you know them, then it is probability sampling. For example, we are having say 100 students, and from 100 we have to choose any 10. Okay, and what is the best way of choosing? 100 लोग हैं और 10 लोगों को choose करना है. What is the best way so that I should be the representative also, and someone should not say that ki my selection is a biased one. What I can do? Every 10th. Okay. And some other idea? How random? How random I can do? You are very close to me. I have chosen you. चिट सिस्टम, वेरी राइट, चिट सिस्टम. ओके, चिट सिस्टम हम लोग क्या कर रहे हैं, तो क्या कर रहे हैं, हमने 100 चिट बना ली, 100 चिट बना ली तो 100 लोग हो गए. अब हम चिट सब आइडेंटिकल चिट बनाएंगे ना, एक जैसी, कलर प्रेफरेंस नहीं रहेगा. हमको पिंक पसंद है, ऐसा नहीं कि हमने पिंक डाल दिया उसमें पिंक उठा लेंगे. सब एक आइडेंटिकल चिट्स बना ली और उसको रख दिया, और फिर हम किसी को चूज़ कर रहे हैं. तो किसी को चूज़ कर रहे हैं तो उसकी प्रोबेबिलिटी क्या हो जाएगी? 1/100. पहले वाली को फिर चिट हमने वापस रख दिया है, फिर से हिलाया, फिर से चूज़ करो, दूसरे वाली की कितनी हो जाएगी? 1/100. सो हियर व्हाट आई नो द प्रोबेबिलिटी, आई नो इट इज़ 1/100 है ना. आई नो द प्रोबेबिलिटी एंड इट इज़ इक्वल फॉर ऑल. If I have such type of arrangement, when the selection of units probability is known to me and somehow it is equal, then we would be saying that I am having a fair selection. If you are doing this type of selection, then we say that it is based on probability sampling technique. Probability का formula हम लोग use कर रहे हैं, favorable number of cases divided by total number of cases, and it is satisfying certain other exams also. I'm not going into that. तो लेकिन ये इसमें क्या है, आप probability निकाल सकते हैं, है ना. तो अगर इस तरह का selection हम कर रहे हैं तो इसका मतलब क्या है कि we are using probability sampling technique. बट इस तरह का selection हम नहीं यूज़ कर रहे हैं, हम probability नहीं यूज़ कर रहे हैं. वो बहुत पीछे बैठा है, हम उसको जानते भी नहीं है. ये लोग हमारे पास में हैं and they are my friends and they would give me a favorable outcome also. I have chosen them. तो based on my convenience I have chosen. तो ये इस तरह का जो selection है, ये आप लोगों को गवारा नहीं है ना कि आपको जो नोन है आपने उनको selection कर लिया. So it is difficult to generalize them. It is difficult to generalize the sampling technique where it is a sample which is not based on probability sampling technique. Okay, but it doesn't mean that only probability sampling techniques are important. Okay, I will give you an example where you cannot have a probability sampling technique. There are many situations where you cannot have a probability sampling technique, or if you are using probability sampling technique, you will not get the adequate sample. Okay. So the concept of probability sampling and non-probability sampling, I hope it is clear to everyone. ठीक है यहाँ तक? Okay. Now, coming on the types of sampling techniques within probability and non-probability. So within probability, we are having 4 types: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. And in non-probability sampling, we have judgment sampling, convenience sampling, quota, and snowball. Coming on the first one, simple random sampling. Simple random sampling, when each and every study unit has equal and known probability of selection, then it is said to be a simple random sampling. For example, we have seen in a lottery system, सबका probability 1/100 आ रहा है, ठीक है. तो अगर सपोज करिए हमारे पास 10,000 लोग हैं और हमको उसमें से 400 लोगों को चूज़ करना है, तो हम क्या करेंगे, 10,000 चिट बनाएंगे. It will be a very difficult one to do a lottery system. In that case, generally we use a random number table. तो random number table में क्या होता है, एक इस तरह की टेबल है which will give you an idea that each and every unit is having same probability of being selected. So randomly वहाँ पे कुछ numbers हैं, उनकी tables है, and randomly if you are choosing from that table, first number, 2 numbers you got 12, second numbers you got 0, 2. So what it is doing, it is nothing, it is just like lottery system. In lottery system what it is doing, each and every unit is equally probable है ना, सब लोग 1/100 है। उसी तरह रैंडम नंबर टेबल क्या है, एक इस तरह का एक बड़ा लॉटरी का सिस्टम है, आपको ऑलरेडी बना के दिया रखा है, कंप्यूटर जनरेट करता है, उसकी मदद से ऐसे करते हैं कि हर एक सैंपल का सिलेक्शन जो है इक्वल होने लगता है। तो when we have to choose a larger sample, we cannot go for a lottery system. In that case, we ask our computers to generate random numbers, and from that random numbers we take the samples. Okay. Second one, systematic sampling. That was she's saying that every 10th individual को choose कर लेते हैं, every 10th individual को choose कर लेते हैं, and whatever the first selection is random. First selection is random. Suppose we are having a class of 100 and we have to choose 10. So randomly I would be choosing any one using random number table or lottery method. पहले का selection हो गया. Then at equal sampling interval. तो sampling interval total sample size which is 100 divided by 10. Every 10th individual को फिर हम choose करेंगे. तो पहला 10th selection हो गया. फिर उसके बाद अगला जो 10th नंबर पे आएगा उसका selection हो गया. इसका एक drawback है, बहुत serious drawback है. If the first selection is not a reliable one, then you would be getting a lot which is unreliable. I have got a practical example of this one. While in my days when I was in Calcutta, in a bakery shop, I have purchased Britannia rusk. Okay, so all the rusk were overcooked. Okay, I am a lazy person, so after 2 days I again went and I again purchased it. Okay, this time also I got baked one, overbaked one. Okay, so after 2 days I again got for the same thing, and this time I got, and this time I thought that I will do something. So I have written a mail to Britannia कि people are corrupt, you are doing such and such things. It was a COVID time, during COVID only. So so they people tell me कि अच्छा sir you give me the barcode, scan it and give us the barcode. So I scanned the bar and have sent them. They checked in the machine, and that particular the lot which we are getting was of particular machine in that area, and that was having fault. So because of that, I was making an inference that the entire product is not good. Okay, but ideally it was not like that. Okay, so this type of biasness generally happens in a quality control if you are using a systematic sampling technique. Okay, days of immunization coverage, day is Saturday. Randomly you got Monday, and you would be getting a sample of Monday. And vaccination coverage, you will say that कि vaccination coverage यहाँ बहुत poor है, and the day fixed is the Saturday one. Okay, so this type of sampling technique require less money, but yes, one should be conscious while choosing the first sample. Third one, stratified sample, as the name says, stratified it is. Okay, we are having a sample group of individuals who are very heterogeneous. In the inauguration session, we were having the population which was very heterogeneous. Okay, and suppose we have to make an inference on, say, average income drawn, and randomly any one individual from this and any one individual of our working class are come in the same category, and we got the average income is 1 lakh and above. Okay, it will come na, because it is extreme population having higher income, the staff is having a lower income, and we know that the average is affected by the extreme values. So what will happen, the average which we will be getting will not be the reliable one. Okay, so in that case what we have to do is that we stratified the population, we divide the population. So in stratified sampling, what we do, we divide the population in different strata such that within the strata it is homogeneous, and in between the strata it is heterogeneous. Okay, so we will be making a group of professors, we will be making a group of assistant professors, we will be making a group of students, we will be making a group of the other staffs, and then we will be using simple random sampling technique. Then we will be getting the ideal representative. Okay, so this was your probability sampling technique. Non-probability, as says, it is generally depending, it is of 4 types. Judgment sampling, based on the judgment of the PI. He feels he is studying a disease and he wants to know the etiology of a particular disease. He feels that a particular sample is very important for me, so he will incorporate that sample in his study. Convenience sampling, as the name says, based on the convenience we are choosing the sample. Okay, we are doing a MD thesis, and I cannot plan a multi-centric study. Okay, because for the duration, whatever the duration of the data collection is there, it is fixed. I cannot expect that he would be able to cover all the samples. So based on my convenience, I will say that from our RSTC or from our hospital only, we choose the sample. Quota sampling. Sometimes the cost involved in stratified sampling is such a high that the PI decides that he would be using he would specify certain quotas. From the first data, I would be choosing 60%. From the second quota, I would be choosing 30%. And from rest all the quotas, I would be choosing a lesser percentage. So based on the his view, he is drawing the samples. The last one, snowball sampling technique. Snowball sampling technique, suppose you want to study the prevalence of domestic violence in a rural area, okay, and आप फील्ड में जाएंगे, you are using simple random sampling technique, ठीक है, लॉटरी से निकाल लिया, हाउस नंबर ये आ गया, आप उस हाउस पे जाएंगे and you will ask that house पे जो बी लेडी है उनसे whether the domestic violence is going on, will she answer you? उसके साथ हुआ हो ना हुआ आपके साथ हो सकता है, okay. So in that case, you will not get, from using any probability sampling, you will not get the sample. So what you can do is that you will try to find it out कि कहाँ पे इस तरह का एक केस हुआ है, ठीक है, and during a favorable time you can visit her and you can ask her कि और कहाँ हुआ है. तो फर्स्ट सैम्पल विल गिव यू द लीड कि हाँ उसके साथ भी हुआ है, उसने रिपोर्ट नहीं किया. सेकेंड वाला भी बताएगा कि हाँ उसके साथ भी हुआ, शी हैज़ नॉट रिपोर्टेड. लाइक दैट ईच एंड एवरी सैम्पल इज गिविंग लीड टू द नेक्स्ट वन. सो लाइक दैट योर snowball is again reforming. So using the snowball sampling technique, you can get the adequate sampling technique. So these are our non-probability sampling technique. Stratified, जैसा हम लोगों ने बोला है, stratified में we are dividing the population in different strata such that within it is homogeneous, in between it is heterogeneous. In cluster it is just reverse. We are dividing the population in different clusters such that within it is heterogeneous and in between it is homogeneous. So क्या करेंगे, ideally randomly किसी भी cluster को पढ़ लेंगे, तो किसी भी cluster को पढ़ लेंगे और we would be having the idea about the entire population, what's going on. Why we are doing cluster sampling? Sometimes what happens, it is easy to study the institutes or groups rather than individual. For example, if I say what is the prevalence of the students who are studying different board examine, है ना, कोई यूपी बोर्ड से पढ़ रहा है, someone is studying in ICSE board, someone is having CBSE board. So if we are having individual, we are doing a survey and we are asking individuals what board you are following, you may not get the adequate size. But what ideally we can do is that we can study the schools. Okay, this school is of CBSE, this school is of ICSE. Okay, so here what we are doing is that we are dividing the entire population in different clusters such that within cluster we would be having CBSE, ICSE, UP board, other board. In the second cluster also we would be having the same information. So both the clusters are same, in between it is same, but within it is different, and randomly we can choose any cluster. Okay. Whenever we are talking about probability, non-probability sampling technique, the only problem is that it is difficult to generalize. Okay. So when you are saying that I have used convenience sampling, for example, I am in my hospital setup and whatever the patient we are getting, we are choosing them only. Yeah. What happens is that the only thing is that the sample which are coming in our hospital, say we are having the patient from Sonbhadra, we are having the patients from Odisha, and we are having patients from different districts, different states. So it is difficult for us to identify the population from where we will be generalizing our finding. If we are doing a study on RSTC or USTC, there we would be getting local population of Varanasi only, and then we can say that कि RSTC and USTC जो एरिया को कवर कर रहा है वहाँ पे हम जनरलाइज कर सकते हैं. लेकिन हॉस्पिटल सेटअप्स में ये प्रॉब्लम है कन्वीनियंस सैम्पलिंग में कि वहाँ पे वी विल बी नॉट be able to identify our population which population it is coming from. So that is only the problem, but it is not that we are not using it, because in many setups there are many things which are very costly things which are only done on the hospitals, can be done on the hospitals. Many diseases are there which are having very low incidences, you will get only in hospitals. So that is the only thing, and otherwise there is no problem.
सर सब सेंटर के पॉपुलेशन को हम जनरलाइज कर सकते हैं?
सब सेंटर के पॉपुलेशन, वहाँ पे आपको पॉपुलेशन डिफाइन करनी पड़ेगी।
सर सब सेंटर एक कम्युनिटी बेस पर ही होता है, जैसे
हाँ, तो उस कम्युनिटी के लिए जनरलाइज कर सकते हैं, जिस जहाँ पे आप कर रहे हैं वो सब सेंटर जितनी पॉपुलेशन को कवर कर रहा है उस पॉपुलेशन के लिए जनरलाइज कर सकते हैं कि इस पॉपुलेशन में ऐसा हो रहा है।
तो ओवरऑल डिस्ट्रिक्ट को जनरलाइज
नहीं, डिस्ट्रिक्ट को जनरलाइज नहीं कर सकते हैं, डिस्ट्रिक्ट को जनरलाइज नहीं कर पाएंगे, क्योंकि वो सब सेंटर पूरे डिस्ट्रिक्ट को कवर नहीं कर रहा है, ठीक है, उस एरिया को कवर कर रहा है, ठीक है। ओके, थैंक यू एवरीवन।